All right. So, like I said, I'm Thor. I didn't actually put any slides together for this, so I'm really counting on the live demo to do what I expect it to do. Bear with me if it doesn't, but so far so good. I've been spending a lot of time lately playing with a chip called the ESP8266. It's a Wi-Fi system on a chip. It's got a 32-bit microcontroller and a Wi-Fi baseband and MAC all built into the die.
And that's it?
I'm sorry?
And that's it?
Well, so the chips themselves, actually, let's see. So they first got popular as modems, essentially, for Arduinos. So people were hooking them up to their Arduinos and just using them to add cheap Wi-Fi. The killer feature about them really is that they cost about $4 if you get them straight from China. You can get them from Adafruit or SparkFun or a few other places for about $8 or $9. There are a bunch of vendors on Amazon. They're really easy to get now. But I ordered these from a company in China and had them, I got 10 of them. They were $3.60 shipped to my door. And they arrived at my house before I did. I was on vacation when I ordered them. So they come in a few different form factors. The one I've been playing with the most is this little guy. This is the 07. This one I chose mostly because it has a mini BNC connector on it for an outboard antenna if you want one, but it's also got the ceramic antenna on board, so you don't need any of that. It actually works very well as is. I started playing with it at my hackerspace upstate, and one of the members was walking outside with my contraption and got halfway around the block before it actually disconnected from our Wi-Fi. So I've been very happy with the signal on it. The more popular one that I've seen is this one. This is the 01, and the 01 has the PCB antenna etched on board. Doesn't have a breakout for the outboard. It also doesn't have the fancy CAN over the chips, but it does have a 0.1 pitch header on it, so it's a little bit easier to interface. The big problem that I ran into with the 07 is that it's got this like 2 millimeter spacing on it on the breakout here, so it was a little hard to interface with. I did find just last week that the company that I've been buying them from has a breakout board with the 0.1 headers on it. I haven't actually done anything with this one, but it's good to see that you've got it. Sure. Yeah. And then this is the little dev board that I hacked together myself. When I got it, I hadn't thought anything about how I would use it, or what I was going to do with it, or what else I might need to get it going. So when it arrived and I couldn't just plug it in and start playing around, right, I dug through the junk box and put together this. There was a lot of discovery on what it takes to get these running, since more people use the 01s than the 03s or the 07s. There are a few more steps to getting the 07s working. There are a couple of jumpers on this board, and those are necessary because certain pins need to be tied high or low to get the chip to boot in the right mode, depending on if you're programming it or trying to talk to it over serial. The specs, the actual memory on this, I haven't been able to find anybody who will definitively state how much memory it has on board, either flash or SRAM or whatever. It's a 32-bit micro. It's got a 16-bit compact mode if you want it. There is now, there wasn't when I first found it, but there is now GCC overlay and an entire GCC Tool Kit. Let's see. Well, there's the spec. So the tool chain, you can build the whole tool chain for GCC. And then there's the open SDK that you can get off of GitHub that will actually do most of the hard work, basically scripting out the build. Their goal is to make as few binary blobs as possible. What's that? It's the manufacturer. That's a very good question. I haven't gotten to the point where I'm actually doing any assembly on it. It is RISC, but I don't know exactly what architecture. It's a proprietary processor with everything built in. It's Espressif Systems, the ESP8266. You can find a lot of documentation on it, but not a whole lot about specifics, right? So like the API docs that I've been able to find from Espressif are the C docs for the SDK that they ship with it, which I'm probably never actually going to use because they also ship an IDE and a bunch of other stuff that I don't want. But it has a lot of features for such a little tiny thing, and especially for something so cheap. So there are also a few different firmwares available for it. So it ships with one. It ships with a firmware that has all AT commands set up. So if you ever talk to a modem over serial in the good old days, right? You know what to expect, but everything that you think will work doesn't. So it's not real AT commands. It's just something they made up that looks a lot like them. It's pretty easy to use once you get to it, right? I mean, the commands, the documentation is there, and it all does just kind of work. I played with it like that for about 30 minutes when I got it. Mostly just doing things by hand over serial, connecting it to Minicom and just plugging away that way. I didn't really find it to be very useful for building anything at that point, so I almost immediately put Node MCU on it. Node MCU is a firmware that runs Lua, and it has a bunch of libraries already built in. Actually, no, I don't want to do that yet. It's got an MQTT library. Well, here's the API. Right, so you can read and write files. It's got all the Wi-Fi. It can act as an AP, a soft AP, or in station mode to connect to an existing AP, which is how I've got it set up now. Rumor has it you can actually do both. So you can have it run as its own AP that you can connect to configure it, which sounds like it's going to be very, very convenient, but I haven't had a chance to play with it to see if it works as well as they say it does. But Node MCU with the timer, right, GPIO, PWM, and then some net stuff in there for opening sockets and serving connections. It's really easy to just get something together on this. And so for that, I'll demo what I have already. How many times does it take? More than 3. There we go. Okay. And it's got the nice satisfying blinking lights on there. I was fortunate with this run and I missed the saga. There was a run of these that were manufactured where I don't know if the parts fell out of the pick and place or the machine just lost its mind, but a bunch of I think the oscillator was on sideways on most of them. A couple of people found theirs actually attached to the board upside down. So it did nothing. I did not have to desolder anything to get mine working. This is just a little prototype to make sure that I knew how to program it, how to get code onto it, how to get it reading a button. You can see it joins there. I have an MQTT server, right, Mosquito, just running on a droplet. Again, it's just a prototype. So this right now will count the button presses, and about every, I think I've got it set to a half a second or so right now, it sends the current count of button presses. Right, and it'll just do that kind of as long as you want it to. The original prototype that I had on this, or the first version of the software I had, I was using, I still am using interrupts to read the button, and the Node firmware that's on there does callbacks. So I had registered a callback, and there was actually a race condition where if I pushed the button fast enough, I could make it reset. And I thought for probably a day and a half that I had a power problem until I actually opened the serial console. I'm sorry? Yeah, it's running a firmware called Node MCU. It's not Node. It's not JavaScript. Right? It's actually running Lua. It takes Lua code with a bunch of built-ins. Yeah. Did you have to write bouncing code? I did. Yeah, I'll show you my code in just a second. First thing. So one of the cool things about it is that even though it's a self-standing micro and it can run itself, every firmware that I've dealt with so far has some sort of serial console on it, right? The AT is all over serial. The Node MCU does the serial console. And so you could do right? And it'll just take Lua commands and you can do that kind of thing. Pretty much as, you know, everything that you do to interact with this actually happens through this console. I'll show you another tool in a second. And this, if I push the button while it's on this, right, it outputs a little bit of debug so you can see what's happening. Oh, there you go. And that actually is precisely the behavior that it had all the time when I pressed the button fast enough. So fortunately, whatever is causing that is a new problem, which I also haven't been able to track down. And it is having a little bit of trouble connecting. Huh. I don't know why it doesn't want to resolve now. Anyway, let's see, let me get out of this. All right, so the code, right? Just set a couple of constants, the MQTT client. Right now, the MQTT server that I have set up is without credentials, but the last two parameters there will give you the creds for it. You can set up a callback so it doesn't actually start publishing any of that stuff until it's actually fully connected. That was another problem that I figured out the hard way. I have it set up right now so on the membership channel, everything will send a join. It sets part as its last will. So when you disconnect it, it'll eventually send timeout and send a part message. And then I have this function, which returns another function specifically for doing the debounce. And it's just, you know, timer based. Nice long delay because I don't actually care about how fast you're pressing the button. And then a little bit of not quite atomicity in there to make sure that, you know, I can publish a count. It misses some button presses, but I figure the number that it misses is probably accounted for equally by the debounce code as the lack of atomicity. And then you just register that as a trigger on the GPIO, right, and it comes up. So it's really easy to get started, get something going on there. There's now support in the Arduino IDE for this as well. So you can write, you know, this Arduino C++y kind of code to write to it. I haven't played with that yet, just haven't had the time. But I'm pretty excited about getting to do that. And then with the, you know, I already showed you the Open SDK, writing directly for it should actually prove to be pretty good. And then the tool that I've been using to upload is called Lua Tool, and I figure running it is probably the easiest explanation for how it works. It really just connects to the console and issues all the same commands that you would to open a file and write into the file, right? Really dirty. And then at the end of that command line, the -R tells it to reset, so it'll actually call the Lua function to reset it so that it'll start again. If we go back here, you can see where it parted because it reset and then joined again. And can I get up to 20 without it crashing? Yes. All right. Let's see. And then one of the cool things about it is that the community built up around this so quickly, right? So here's you saw the Node API documentation as I was going through it, but the ESP8266 community forum on ESP8266.com is actually pretty, there's a lot of information there. So far I haven't even bothered to join because everything I've wanted to know I've either found there or was just in one of the projects I was working on. But the crew seems to be very friendly. They seem to get questions answered pretty quickly. They're tenacious about getting data sheets and specs when they want them. So I hear that signing up for the community actually involves quite the wait. Like I said, I haven't tried it, but one of the Squidwrench members did, and he said it took him about a week and a half or something to get approved. So, and I think, is there anything else? Does anybody have any questions?
All right, so I saw the RFC for HTTP.
Yes, that is definitely a goal. So I haven't figured out if I'm going to do the TEA extensions or not yet, but I'll probably get there.
Can this run without an Arduino?
Yes, right now it's running, this is just standalone, right? So the node is just running on its own there, or node MCU firmware, right? It takes a little bit more setup. It's really not very complicated. You probably wouldn't want to run it with the stock AT firmware because it doesn't do anything on its own except answer the AT commands. But it's so easy to flash something else to it. The only gotcha, really, once I had this all going, is there's a pin that you have to tie low to program it, and then float to boot not into programming and actually talk to it over the serial. So I got everything soldered up, and I could talk to it, but I couldn't program it. Then I took everything apart, put it back together again, and I could program it, but I couldn't talk to it. And then I finally found somebody on a post somewhere talking about how the 07 requires you to tie that down. The 01 has everything set up the way that you need it to make that a lot easier. And the breakout boards have it, like the one that's floating around here somewhere has a button on it, so you can just hold down the button to pull it low. The node firmware is probably not all that good for talking to an Arduino now that I think of it, but the AT commands work pretty good. Yeah.
Now that you've played around with it a bit, do you have any ideas for fun projects to do?
I have more ideas than I can actually get my hands on. So my first project with it is, I got that button working, and I wanted to have the NeoPixel rings working today, but I need a level shifter. It's a 3.3 micro, right? So you need to, and then the NeoPixels are 5 volts, right? So you need the level shifter to do the communication. I didn't have one on hand or any FETs. So that arrived this morning, and I didn't get a chance to take a break and put it together today. But I got a tap light, and what I would like to do, if anybody wants to play along, send me an email, and I will try to get you one when I have them working, is put all of this stuff, the ring of NeoPixels, tie to a button that's in there, put a either a vibration sensor or just a tilt switch in it, and a pager motor, and then get them all tied online so that there's a game that you will be able to play with one button, and it can tell if you move it around, feedback being vibration and lights. I intend to tell no one the rules, but to post a leaderboard so that you can see who's winning. So that's where I'm going to start, and then the coffee pot, right, control, 2 spec, right? You have to go to RFCs or it's not worth doing, right? Right, so get the coffee pot working correctly, right? And then for our friends that drink tea, we can, implement the Flux appliances. And I figure that'll keep me busy for at least a few more weeks. I haven't really gotten too far past that. I've been working on getting power supplies and things to try to build them into switches or light fixtures so we can have Wi-Fi controlled light fixtures. Light fixtures are actually a lot easier because there's just more there to work with. Getting something to power this that will fit into a normal switch box has been kind of challenging. So if you have any ideas for how I can get 3 and 5 volts to fit into a standard electrical box, let me know that too, because that'll be helpful.
How much power does that take?
So I haven't actually gotten it on the scope to see how high the spikes go. Rumor has it can jump up to 0.5 amp sometimes when it's really beating on the antenna. I haven't actually gotten a reading higher than about 240 milliamps. So it does reasonably well. I also haven't played with any of the deep sleep modes or any of that stuff. Apparently, you can tie reset and one of the GPIO pins together and put it into deep sleep and have it wake up on a button press or have it wake up on a timer or something like that, and it's really, really low. They report some specs on it. Yes, they claim standby of less than a milliwatt. All right, so I haven't tested it to prove that per se. I think I've seen, without going into standby, I see it drawing about 10 to 20 milliwatts most of the time, but it's very bouncy.
Protocol support for various IoT protocols like MQTT or co-op?
MQTT is built into the Node MCU library, so you can do that. I haven't really played much with anything else. A lot of people have done, I guess you wouldn't really call it bit banging at that level, but have implemented HTTP on top of various things. I think the next thing, when I feel like I've outgrown MQTT, I'm probably going to move on to like, just doing a raw nano PB kind of protocol, because it looks. I haven't seen anybody that has nano PB running with it yet, but it looks very promising. So, protobus for embedded.
Can it broadcast, or is it only receive mode? Like, can you use it instead of a mesh network or something?
Well, it can join a network and it can advertise. So, as a soft AP, I'm sure that you could bang something in that works. I'm not exactly sure how you would make that work. I haven't seen anything, nothing like Batman or anything ported to it to just get it set up. But I'm sure you could actually pull something together that, as long as it works as well as they say it does in dual mode. So, yeah.
Are the networking APIs in Node MCU similar enough to the ones in regular Lua that you can use all libraries?
I don't actually know the ones in regular Lua. This is the Lua that I've done for this is probably 100,000 times more Lua than I've done for anything else, just by bytes. So let's see.
Is it based on Lua?
It is. The firmware is all open source. It was commercial. The company that makes the Node MCU firmware also offers some pretty nice looking dev boards. I don't know anybody that's actually gotten one to work with. But after they had it out for a while, they did open source the firmware, so it's all there. It looks like they do have an HTTP module in it now. Redis client. So you can extend it. I haven't tried to extend it with anything myself. Yeah. With the Google Smart Home?
Yeah.
That's a good question. I don't know how to interface with any of the, right? Okay. Well, I mean, it gets on Wi-Fi, so if you have any Wi-Fi control at all, right, you can probably use it to do something. Like I said, I'm trying to get it to control switches and some mains level relays and things like that, so that I can, at the very least, turn stuff on and off or do some kind of intelligent things. At the end of the day, it is still a microcontroller, right? So you're kind of limited in what you can do, but by all estimates, it's about 4 times as much power as an Arduino, right? So you kind of limited is still kind of a lot, right? Probably approaching my first computer, right? Say again? Oh, X10, right? So my experience with X10 is that most of the commercial hardware that you get is fairly range limited. So if you're doing anything more complicated than a burst of on or a burst of off messages, you're probably not going to get through. Right. So in the house, my hackerspace is in this building that's all plaster and lath and like just weird runs of conduit and cell phones hate being inside the place. And like I said, one of the other members walked outside with this and was halfway around the block before it disconnected. So he was just sitting there clicking away happily, and I was watching it count. And you know, he did about 1 per pace, and I think we got up to 200 and something before it disconnected. Yeah.
Can it work as an access point?
Yes. No, that was just with the ceramic. This has a ceramic antenna on it, which is one of the reasons I chose this one. I don't know how the PCB antennas compare on like the O1s and the O3s. I think that the 12 is a very similar form factor to the 07 that I'm using, and I think that also has a PCB antenna. So I would guess that the range is a little bit less on those, but I haven't done any empirical testing. In fact, you watched me open the very first 01 of the batch that I bought. So let's see. Does anybody have a Wi-Fi? Are you on Wi-Fi or? Yeah. Okay. Would you like to try an experiment?
Sure.
Let's see. Yeah, if I can get back to the API. I can. Oh, right. Backspace doesn't work the way that you want it to. So live coding is probably a bad idea.
There it is.
Oh, you see it already?
992A05.
Nice. Will it, it's open? Will it let you connect? Okay, so let's see what the, let's do this. I don't even know if this is the right syntax. No. Yeah? Cool. No, why am I? Oh. Let's see. Nope. All right, I'll have to work with that. I guess that was a failed experiment, but at least we know it can come up. Let's see. So it's advertising and still on the network. At least we know that part works.
So just to clarify,
Yeah.
You had it connected to the one Wi-Fi network, and you're also broadcasting a second network.
Yes, it is. So it's still connected to the guest Wi-Fi here, and then it is advertising at least. I haven't figured out how to get the syntax correct because, like I said, Lua is not exactly my forte. So, but it did. As soon as I put it in access mode, station AP, it started showing up. So that's definitely promising. Other questions?
So that's a random question. I don't know anything about this, but so Wi-Fi is like a kind of standard. It does like the G-band or B-band, but there's kind of a interest in this kind of localized like mesh networking.
Mm-hmm.
Is there any interest in like dedicating some spectrum to low power like adjacent versus kind of large broadcast like Wi-Fi?
I haven't heard of anybody doing anything like that in the Wi-Fi bands, or at least not as a part of the Wi-Fi standard. I mean, that's sort of the same thing that like Bluetooth and now BTLE are trying to cover, and there are a few other things similar to that that people are working on for that kind of problem. I haven't heard of people crossing, but I'm not an EE either, right? I'm just a jerk that does this in the spare time, so.
Have you tried to bomb it out with many connections and see like where it lacks in like speed or?
Not yet. Nope. I would definitely like to see where that happens. I've heard rumors that it doesn't really actually take all that much. So, but you know, for a $3, $4 microcontroller, right? That's if you're willing to spend 20 bucks or whatever, you can get you know, just an access point that you can JTAG into and just overwrite with another firmware to get something that's going to have a little bit more oomph if you want to do something that's actually serving a lot of clients. So it seems so far to be best suited for just, you know, for smaller, like, you know, reporting back sensor data and handling some more basic stuff like that. It's a little overpowered, obviously, for just reading, you know, like one thermometer. You know, you wouldn't want to replace all your 433s with that. Any other questions? Yeah. That aren't Lua? It depends on how much you work with embedded or micros in general. Yeah, so definitely C. You know, with the overlays and the Open SDK, you can do C. I don't know about C++. I'm a little, you know, for embedded, C++ kind of scares me. You know, it has a tendency, or at least in the last time I used it extensively, it had a tendency to make some giant blobs, right? But you could probably get it to work, right? If Arduino works, then C++ has to be not far, you know, full-fledged C++ has to be not far behind. And so if you're used to doing stuff on the command line and just kind of doing it by hand with whatever tools you have already, right? I would say get the Open SDK and probably go after that. I haven't done it myself, so I don't know how well it works just yet, like just because I haven't gotten that far. But that's probably the next step for me. And then if you're not as used to working with micros, I would say if you really don't want to use Lua, then go for Arduino, just because the IDE is kind of hard to beat for stuff like that. Anybody? Yeah.
What kind of Wi-Fi band?
I think it does. It definitely does N. I think it's BGN, honestly. That's why I had this up. Yeah, BGN. So, and it does peer-to-peer. All right. So if you want to talk about it some more, feel free to grab me, and I will, you know, be happy to tell you anything else that I know if we haven't already exhausted my knowledge. And again, feel free to send me an email, thor@digitalocean.com or thor@doco. And if you want to play that game, let me know, because if I can get more than, say, 2 people playing, I bet it will be a lot more fun. So, all right. Thank you.